The digital computer. Definition 1. A digital computer is a system intended to automate computations on discrete information in accordance with given algorithms. Definition 2. A digital computer is a union between a set of physical equipment, the hardware component, a set of microprograms, the firmware component, a set of programs representing the software component, allowing processing by means of architectural and logical operations of the discrete information at very high speed in accordance with given algorithms. Definition 3. A digital computer is a finite automaton, that is a finite state system capable of processing at a very high speed discrete information in accordance with given algorithms. 3 levels: computer architecture, computer organization, computer implementation. Computer architecture refers to attributes of a system visible to a programmer that have a direct impact on the logical execution of a program. Deals with the functional behavior of a computer system as seen by a computer programmer. The nature of data types, range of realized operations, memory organization, the set of registers that are accessible to the programmer, the instruction set and formal addressing techniques, I/O mechanisms. Computer organization refers to the operational units and their interconnections that realize the architectural specifications. Organizational attributes: hardware details transferred to the programmer, such as control signals, detailed structures of functional blocks, interfaces between the computer and peripherals, memory technology, extension techniques, clock frequency, etc. Computer implementation: the actual hardware, actual physical structure, including logical design techniques, board layouts, physical interconnections, power supply, testing methods, interface between signals, mechanical design, etc. The von Neumann Principles. Principle number 1. The information within a digital computer is binary coded, which means that it is represented with binary digits, named bits, 0 and 1. The term bit is an abbreviation for binary digit. 8 bits is a byte, 16 bits is half a word, 2 bytes. 32 bits it's a word, 4 bytes. 64 bits it's a double word, 8 bytes. A word may represent a command, instruction, or a datum. There are defined 2 kinds of words: datum words, data; command words, instructions. Principle number 2. The distinction between data and instructions is given by the utilization context, the way of word utilization, and not by the coding method, coding rule. Considering a binary combination on 8 bits, it can be interpreted as a numeric datum or an instruction. Inside the computer, the code is the same, both for the data and for commands. It is the task of the user, by the way of manipulating the information, to ensure proper distinction. Principle number 3. The words are placed in memory locations. Every memory location is being specified a specific number, called address. Every data word or instruction word is located, stored, in a memory at a certain address, so that the address is a pointer to that word. 2 operations: read and write. Read extracts a word from the memory. Since it is a non-destructive operation, it is obtained a copy of the word located in the memory at a specified address. The content of the location itself remains unaltered. Principle number 3. Write implies insertion of a new word in the memory at the addressed location. Principle number 4. The running algorithm is represented by a means of a sequence of command words, instruction. In general, any instruction is formed of two major fields or zones: the operation code, opcode, and the address. Opcode, also called the function of the instruction, addition, subtraction, multiplication, complementation, division, etc. Principle number 5. The data processing performed by the processor is determined by the sequential instruction execution, constituting the program for the implemented algorithm. So, computation program is a set of instruction. A computer can accept a finite set of possible programs. This range depends on the computer capabilities. The set of accepted programs by a computer is the class of realizable functions of a digital computer. Conclusion. The main feature outlined in this principle is the procedurality in solving any problem submitted to a digital computer, materialized in an algorithm and a program. So procedurality, any program must be presented to the computer as a sequence of operations, i.e., a sequence of instructions. The von Neumann model. In conformity to the von Neumann principles, a digital computer is a system formed out of several subsystems or units. A digital computer must consist in 5 units: an input medium, a storing medium, a processing section, an output medium, and a control section. An input medium, by means of which an essentially unlimited number of operations, data items, or instructions may be entered. A storing medium, from which operands, data, and instructions may be obtained and into which the results may be entered. A processing section, capable of carrying out arithmetic or logical operations on any operands taken from the storage. An output medium, by means of which an unlimited number of results may be delivered to the user. A control section, capable of interpreting instructions extracted from the memory and capable of choosing between alternative computer results. So the 5-unit structure: input unit, IU, arithmetic and logical unit, ALU, memory unit, MU, output unit, OU, control unit, CU. Functioning. IU and MU transfer data via DMA, direct memory access. Data and programs are introduced inside the computer through the IU. IU informs DMA about the presence of data and programs in the IU. DMA informs control unit about the presence of data programs in the input unit. Control unit sends a command to the direct memory access to start the transfer of data programs. Direct memory access forwards the command to the input unit. Input unit begins the transfer to the data memory access. Data memory access transfers the data programs to the memory unit. Same happens for the memory unit and output unit transfer via data memory access. Direct memory access. Whoopsie.